Okay, we are starting our topic today on vectors. And vectors is probably something that you have not done much work of unless you've taken a physics class. We may have touched on it briefly in geometry, but I don't even think it was tested over anything. We may have talked about vectors. So this is probably something new, although the math behind it is not going to be new. Okay, it is not a difficult concept as far as the math is concerned. It's more understanding how to apply vectors to story problems. That is probably the most difficult part. The math, you've already done it. The trig that you've done this year so far, it's simple. Okay, so don't be worried about that. But I need to go through kind of a lot of vocab to help get us started. So a vector is a quantity described by magnitude and direction, which is exactly what vector says in Despicable Me if you watch it.
Yeah, both directions and magnitude.
So anyway, quantity described by magnitude and direction. An example in words would be something like this. 40 miles per hour at 20 degrees south of west. That has both a magnitude, the 40 miles per hour is our magnitude part, and the 20 degrees south of west, that is our direction part. Okay? You must have both for it to be a vector. Okay? Both magnitude and direction. We usually represent vectors with an arrow. Okay? So I kind of gave an example right here. So this was my vector kind of in words, and then here it is using an arrow. If you don't know your directions, get to know them. Okay, north we went up, south is down, west is to the left, east is to the right. Okay? So what I did was I drew an arrow, labeled it 40 miles per hour. It's kind of like the length of the arrow, if you want to think of it that way. Okay, even though it doesn't represent a length, in this case it represents a rate. Okay, but you can kind of think of it as the length. And 20 degrees south of west. So if here's west, and I go 20 degrees south of that, okay, that would be how I would draw that vector picture there. Again, magnitude is the length, and direction is the degree measure. Magnitude is the length, and direction is the degree measure. And we measure it from the positive x-axis, like I talked about before, 0, 90, 180, 270, 360, or we'll just use directions, kind of like I did here. I think it's easier to use directions. If you go into physics, I think it'll help you talking about directions that way. It's kind of odd, but in physics, they actually have a little different way of describing angles. 0 degrees is actually north in physics, and then 90, and then 180, and then 270. Okay? There's a reason for that. I'm not going to get into that, but it is something that is different in physics. Okay? What I would like to see you do, where I guess the answer is already up here because I'm doing the video, I'm going to go ahead and talk about them. But if I asked you to draw a vector that represents a 12 newtons of force at 100 degrees, okay? If I asked you to do that, what quadrant would you draw that arrow in?
Second quadrant. Second
quadrant, right? Okay? Because 100 degrees, we know this is 0, straight up is 90, so 100 would be in the second quadrant. Black folder down the bottom shelf. So I did that. I drew this vector. Okay, I'll erase some of this other stuff later. But what you see right here in red, that is an example of you drawing a vector with a 12 Newton force at 100 degrees. 12 newtons is the magnitude. So I label the length of that vector with 12 newtons. And then I'm trying to show you that it's at a direction of 100 degrees, so I can either put 100 degrees here, or I could put 80 degrees down there. All right? Anyway, you can just make sure you know what the angle would be. Then we did another one in the other class. It said draw a vector of an airplane flying 300 miles per hour, 50 degrees west of north. And so that example you can see right here. If this is north, and west is that way of it, and I want you to go 50 degrees west of north, it's like you're just taking this and you're rotating it 50 degrees. So that angle right there would be 50, which means this angle right here would be 40, right?
Yeah.
Does those two together make 90?
Yeah.
All right. What are your questions so far? You know what a vector is, right? When I draw an arrow, what part of it's the magnitude? The length of the arrow is the magnitude. What part of it is the direction?
Degree.
The degree measure, the angle, right?
How do we know the length of it?
That'd be given to you. But when I talk about magnitude, I want you to understand that magnitude is going to be represented by how long the arrow is. Okay? So if I say we're pushing on something with a force of 75 newtons, when you draw your arrow, you're going to label that arrow 75 newtons to represent the length of that
So
arrow.
magnitude in this case would be like the miles per hour.
In this one, the magnitude would be the 300 miles per hour.
Yeah.
The direction would be 50 degrees west of north, or you could say 40 degrees what?
40 degrees west. Where's
North.
north of west?
North of west. Yep.
Makes
You could
sense.
say 40 degrees north of west.
Well, then would that be? Well, then wouldn't that 50 degrees be like west of north?
50 degrees west of north. Yep.
Okay.
They're the same thing.
Okay.
Yep. Okay. So far, so good
Yeah.
on introducing vectors. Okay. Sometimes when you're working with vectors, you'll want to put them into horizontal and vertical components. Okay? That's kind of my next topic here, is horizontal and vertical components. And they'll be written kind of like an ordered pair, except instead of nice parentheses, there'll be kind of pointed parentheses on them. Okay? And if you see those pointed parentheses like that, you know you're dealing with the horizontal and vertical components of a vector. And let me try to explain a little bit more on what horizontal and vertical components are. Let's steal this chair. Okay. I'm going to do kind of a quick example here. I'm going to come back to this situation. A 12 Newton force at 100 degrees. So let's say this chair is the object that I'm going to put this force on. Okay? And I'm going to say this is kind of our north, or our 90 degrees. Okay? To the right, this is going to be my 0 degrees. So it's like we're looking down on this chair from the ceiling, okay? And then we got our coordinate system right here. So this would be the y-axis, this would be the x-axis. So if I push on this chair with a at 100 degrees with a 12 Newton force, would you agree that the chair would probably move in that direction?
Yeah.
Because 0 degrees is straight over here, 90 would be straight up this way, 180. So if I'm going to push on it with a 12 Newton force at 100 degrees, it would go that direction. Just a little bit to the left of 90. Does that make sense? Okay? When I'm pushing on that chair, okay, do you understand that, again, if you're visually looking down at it, that it's getting both a force vertically, or up and down, and a little bit of a force horizontally at the same time? I'm not just pushing the chair straight vertically, straight up and down. I'm also not pushing the chair straight horizontally. It's getting just a little bit of both, right? Do you guys follow that concept? Okay? We will want to break vectors down into its horizontal and vertical component using the trig we already know how to do, because that will benefit you when we have to add multiple forces together. And what I mean by that is two forces acting on an object at the same time. Okay? Another example, because not many people just sit around pushing chairs at different forces, okay? if you're swimming in a river or boating in a river. River has a current, right? If you're trying to go straight across the river, are you going to aim your boat straight across the river? You better aim a little bit where? A little bit higher, right? A little bit upstream. Because as you are trying to go this way, the current's going to push you back, so then you can get to your result that you want to go. Okay? That's an example of two forces acting on an object at the same time. And we'll kind of do that with vectors and describe those situations and figure out what angle you'd have to aim in order to get where you wanted to go. Or with airplanes and wind, okay, that's probably calculated all the time in real life. Okay, if you got big crosswinds or tailwinds, that's going to affect the direction you're traveling. Okay, so you have to get the correct heading so you end up where you want to go. All right, so those are the type of story problems that we're going to have eventually here with vectors, and it'll be helpful to break everything down into x and y's, horizontal and vertical components. Okay, it's really pretty simple to do. Let me come back to this picture right here. This 12 Newton force at 100 degrees that I just talked about with the chair. Yeah, let's say I asked you, what is the horizontal and vertical component of that vector? Okay. All that is, if I draw my vector, make a right triangle, the horizontal component is simply the x value, and the vertical component is the y value of that vector. If we know this is 100 degrees, we know that is 80 degrees, we know this is a right triangle. Because we have a right triangle, are you able to figure out missing sides of that right triangle, given we know the hypotenuse?
Yeah.
Yeah. You would say the cosine of 80 degrees equals what? The cosine of 80 degrees equals, don't be shy, come on. Cosine is adjacent over hypotenuse, so x over 12. So cosine of 80 equals x over 12. And you can see this written already here. Okay. Multiply both sides by cosine, and you would solve for x. You get about negative 2.1. Anybody do that yet? Okay. I'm seeing yes.
Wait a second. How do you do this?
I'm solving for x, and I have x divided by 12 equals cosine 80. So what do I need to do to both sides? Multiply by 12. So x will equal 12 times the cosine of 80.
I thought you said multiply both sides by cosine, and I was like,
Nope.
okay.
So that should give you your negative 2.1. And then the sine of 80 equals y over 12. So again, multiply both sides by 12, and you should get your y value. In this case, it's 11.8.
Wait, is it only is it negative because it's in the second quadrant?
Yes.
Like this one, like when I got calculator, it said positive.
Oh, correct, yes. Yeah, when you take 12 times the cosine of 80, it's giving you a positive answer. However, you can tell that the x value needs to be negative because we're up here in the second quadrant, right?
Yeah.
So make sure when you write your answer, you're taking into account positives and negatives. Yes, sorry. So when you're pushing on that chair, if I wanted to label them, I certainly could. When I was pushing on that chair with a 100, at 100 degrees at 12 newtons of force, it was getting negative 2.1 newtons of force horizontally, which means it was getting 2.1 newtons of force to the left. At the same time, it was getting 11.8 newtons of force vertically, up or down, up in this case. Okay? So those would be your horizontal and vertical components of a vector. So far, we know what a vector is, we know how to represent it. We can talk about a vector using magnitude and direction, or we can talk about a vector using horizontal and vertical components. So far, so good?
Yeah.
Okay?
I'm just wondering, when are we going to use